Hey y'all. This is going to be a quick lesson on polygons and quadrilaterals. It's what we would have covered as soon as we were done with, or semi-done with triangles. So there are some things I want you to know about polygons and quadrilaterals. So I've got them in this little presentation here for you. We're going to go over a few things. If you stopped by school to pick up your paper packet, then there are a couple of worksheets on polygons and quadrilaterals. It goes a little more in depth than what we're going to do on this presentation. So if you have any questions or you get stuck on something, if you'll take a picture of it and then send it to me through a remind, I will get back with you about that as soon as I can. I like this. I hope that you do too. So the first question is, what is a polygon? I know that it's a shape, but what is it exactly? It's a plane figure with at least 3 straight sides and angles. So basically, it's not a circle. Polygons can have infinitely many sides, and some would argue, I guess, that a circle could be, but we're not going into that right now. There's pictures of just a couple of different polygons right here. What we're going to talk about mostly with this is the sum of the interior angles. The sum of the degrees in any polygon, so that just means you add all the angles on the inside, can be determined by the number of triangles that can be drawn within the polygon. And I so wish we were at school so I could show you this a little more in depth, but this is something that I actually did not know until I started, really digging deep teaching this class. Inside of every polygon, you can draw triangles. So the first one is a triangle, obviously. It has 3 sides. A triangle makes one triangle. And then the sum of the interior angles is 180 degrees. And you know that. We've been talking about triangles for weeks now. The next shape is one with 4 sides. A 4-sided shape is called a quadrilateral. A quadrilateral can be divided into 2 triangles. So a shape with 4 sides has 2 triangles on the inside, and the interior angle sum is 360 degrees. So add all 4 of the angles together, you'll always get 360, and that's with a quadrilateral. The next one is a 5-sided shape. That's called a pentagon. A pentagon, 5 sides, has 3 triangles. The interior angle sum is 540. So 5 sides has 3 triangles on the inside, and then all the angles add to be 540. And then I'm just going to go ahead and pop this information up here. I don't know if you can see these two because my face is right here and I really don't know how to make it go away. This says nonagon, Nonagon. And this says decagon, Decagon. Something that I want you to notice right here is that for however many sides there are, if you take 2 from it, that tells you how many triangles. Like 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4, and so on and so forth. That's a pattern. And that's how they came up with the formula to figure out the sum of the interior angles in a triangle. So here's your formula. S equals n minus 2 times 180. S represents the sum of the angles. That's, usually what you're going to be looking for. N is the number of sides on the polygon. So you take the number of the sides on the polygon and subtract 2. That tells you how many triangles there are. And since the interior angles of a triangle add to 180, you take how many triangles are in the shape and multiply it times 180, and that tells you what the angles inside of that polygon should add up to be. I'm going to practice a couple. It says this: find the sum of the interior angles of a 23gon. So you're going to use your formula right here. And there are 23 sides on a 23gon. So you just stick the 23 right there, and then it's straight calculator work. 23 minus 2, and then multiply it times 180. you should get 3,780 degrees. So that's what all the angles inside of a 23-gon add up to be. All right, the next one I want you to do is the sum of the interior angles of a 17-gon. So if you'll pause the video, plug your number into the formula, work it, and then come back and check and make sure you've got it right. (17 minus 2 times 180 is 2,700 degrees. All right, so interior angles of a regular polygon. So there's a difference just in polygon and regular polygon. A regular polygon is a polygon in which all sides and angles are equal. And the only one I think that we had really dealt with was an equilateral triangle. So a regular polygon, all the sides have the same measure, all the angles have the same measure. The formula is S divided by N. So S divided by N. S is the sum of the interior angles, so that's the formula from the previous page. N is the number of sides. So you take all of the angles added together and divide it by how many sides there are, and that tells you how much one of the angles would be. All right, what is the measure of each interior angle of a regular hexagon? So regular is important. That way I know that all of the angles and sides are the same size. First thing I need to do, though, is find the sum of the interior angles. So I'll use that formula from the previous page. There are 6 sides on a hexagon, and the measure of all the angles added together in a hexagon is 720. Since 720 is the sum of the interior angles, in my formula that will be my S, and then the N is the number of sides, that's 6. So 720 divided by 6 is 120 degrees. All right, I want you to try this one yourself. What is the measure of each interior angle of a regular 20-gon? Let's pause the video, and then when you've got it, resume and make sure you got it right. Find the sum of the angles inside the 20-gon first. And then take the sum of the angles, divide it by the number of sides, and each angle of a regular 20-gon is 162 degrees. Right. The last thing I want to talk about is exterior angles of a polygon. So exterior means outside. So this is like saying that the line of the shape is extended and now you've made an angle on the outside of it. Exterior angles are always supplementary to their adjacent interior angle. The sum of the exterior angles on any polygon is 360 degrees. That was always really cool to me. Like, it didn't matter if it was a triangle or if it was a 87-gon. All the exterior angles added together would always equal 360. So that's going to be it on polygons. This is not the end of the video, though. There's some quadrilateral stuff, but there is a worksheet in your packet with the polygons. And if you get stuck on there, send me a message and I'll be glad to help you. Otherwise, let's move on to quadrilaterals. This is just going to be a ton of information, and you'll take that information and apply it to the sheet in the packet on quadrilaterals. So this might be, you write all this down if you want, or screenshot it, something. This might be something you want to be able to reference quickly while you're working on those sheets if you picked them up. But a quadrilateral is a 4-sided figure, and there are so many different types of quadrilaterals. The first one I want to talk about is the parallelogram. And I've got a parallelogram here. It's all marked up. We'll talk about what all those things on there mean. The first thing is, in a parallelogram, opposite sides are parallel. So the little arrows here, this one has 2, this has 1. That means that the opposite sides are parallel to each other. The next thing is opposite sides are congruent. So this green side here is congruent to this green side. I know that based on the little tick marks. And then this pink side is congruent to this pink side. Again, I know that because of the little tick marks. Opposite angles are congruent. So A is opposite angle C. They are congruent. I know that because of, first off, because it's a parallelogram, but second, because it's marked here with the little blue. And then D, angle D, is congruent to angle B. Those are opposite angles. Consecutive angles are supplementary. Now, the word consecutive means one right after the other. So angle A, right after that is angle B. So angle A and angle B added together should equal 180. Angle A is also consecutive to angle D. That's one right after the other. So those added together should equal 180. Same thing with D to C or C to B. The diagonals bisect each other. So if you'll look, going from one corner to another, from D to B, that's a diagonal. It's cutting straight through the middle. And it is being cut in half by this diagonal right here. They're congruent. So this piece is cut into this one. It's bisected. And this piece is congruent to this one. It's bisected. The next quadrilateral I want to talk about is a rectangle. Rectangles have all the same properties as parallelograms plus the following. All four of the angles are right angles, so they all equal 90 degrees. The diagonals are congruent. So now, not only are the diagonals bisected, they're also congruent. So if this one was 15 centimeters, then this one is also going to be 15 centimeters. The next one is rhombi. Rhombus is singular. They have all the same properties as parallelograms, plus the following. All four sides of a rhombus are congruent. I know it doesn't look like it. It doesn't look like it to me, but they are. They're all exactly the same size, and that's marked right here by these tick marks. The diagonals are perpendicular. Here's what that means, why it's important. Again, I know it doesn't look like it, but this diagonal and this one are perpendicular lines. And we learned previously that perpendicular lines make right angles. So all four of these angles right here are right angles. The diagonals bisect opposite angles. So this diagonal right here is cutting angle C in half. So if this portion right here was, let's say, 50, then this portion right here is also going to be 50. All right, squares have all the same properties as the other three we just talked about. So parallelograms, rectangles, and rhombi. These are all the properties of squares. And I'm not going to read them to you. I know you can read, so you can pause and screenshot or whatever you need to do. But here's a picture of a square and all of the properties. The next thing I want to talk about is a trapezoid. There are two kinds of trapezoids we're going to talk about, just trapezoid and isosceles trapezoid. This is just a trapezoid. Only one pair of opposite sides are parallel. So here's my little arrow, and here's another arrow. That means these two sides are the ones that are parallel. On a trapezoid, the parallel sides are called bases. So if they're parallel, they're called a base. The other two sides will be called legs. Consecutive angles are supplementary. So again, consecutive means one right after the other. So this angle and this angle added together equal 180. In an isosceles trapezoid, the sides that are not parallel, the ones that are called legs, here's the big difference. Those are congruent. So if this one was 8 inches, then this one's going to be 8 inches as well. And you see that my two bases are still parallel to each other. Diagonals are congruent. So from this corner to this one, and this corner to this one, those two lines, those diagonals, are congruent to each other. The base angles are congruent. Base angles are the ones that are actually on the base of the trapezoids. So remember, trapezoid has two bases. So here's one. Here's an angle here with a blue, and this angle. Those will always be congruent. Same thing goes for the bases up here. Those will always be congruent. Opposite angles are supplementary. So this angle will be supplementary to this one here. This green angle is supplementary to this blue one in the corner. Those are opposite from each other. The last thing I want to talk about with you with the trapezoid is mid-segment of a trapezoid. And you got your picture here. This is illustrating the mid-segment. And the first thing that I notice is the mid-segment is parallel to the two bases. It connects the midpoints of the legs. So this is a leg and this is a leg. The midpoint is here and here. So this line is just connecting the middle of those two pieces. The length of the mid-segment is equal to the average of the two bases. So this is a base and this is a base. And if I had numbers here to find this, how long this mid-segment is, I would take this base, add it to this one, and then divide by 2. That would tell me how long the mid-segment is. That's going to be it for this one. I hope that this gave you some sort of base knowledge, working knowledge of polygons and quadrilaterals. Any questions, whatever you got, shoot me an email in school email, or Remind would probably be faster if you signed up for that. Here are my picture references, so credit's given where credit's due, and thank you.